Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
We're told that we have two rods of equal length. So the length of the aluminum rod is the same as the length of the tungsten rod, and they're combined end to end. And we're asked to figure out the composite Young's modulus, given the fact that we know the composite moduluses of aluminum and tungsten, which I have written out here. Okay, so to do this, we're going to first consider the fact that we're adding the lengths of the two together. So the length of the composite, delta LC, or at least the change in the length of the composite from compression, is going to be equal to the change in the length of the aluminum, delta LA, plus the change in the length of the tungsten, delta LT. Well, from our force relationship between the force, the Young's modulus, the change in the length, the original length, and the area, we have F times L naught over A, because the force, the area, and the length of each one is the same. So we can pull those out. And then this is going to be 1 over y sub A plus 1 over y sub t. So what we're saying here is that delta LA is FL naught times A, or FL naught over AYA, and delta LT is FL naught over AY sub t. So we just pulled the FL naught A out front since it's common in both. We have this expression. Okay. But another thing we must consider is that the composite Young's modulus by itself, y sub c, is also by definition equal to the force times delta L c, times L naught c, the initial length of the composite, divided by the area times delta L C. But we just got an expression for delta LC, and we know that the length of the composite is 2 times the original length of each one, or 2 times L naught. So this is F times 2L naught divided by A. And now we're going to simply replace the delta LC with the above expression. So first we can simplify it a little bit. So 1 over YA plus 1 over YT. This can be simplified. So this is F L naught over A. And this is going to get multiplied by Y sub A plus Y sub T divided by Y sub A times Y sub T. So that's just using some algebra there to simplify what's in the bracket. So now if we plug in that value for delta LC into our expression, and since it's in the denominator, it gets inverted. So what this is A multiplied by Y sub A plus Y sub T, or excuse me, Y sub A times Y sub T, because it's inversion, divided by FL naught times Y sub A times Y sub T. Okay, and so some things cancel here. So these two force values are the same, so they cancel. That L naught cancels with that L naught, and that A cancels with that A. So what we're left with is this being equal to 2 times Y sub A times Y sub T divided by Y sub A plus Y sub T. Plugging all of these values into this expression, we find a Young's modulus for the composite, and it is equal to 1.6 times 10 to the 11 newtons per meter squared, which we can box in as the solution to our question.